Hey, I'm Bob Plankers, and I am talking about security and compliance, security and trust, actually. Compliance is one thing, security is another thing, and trust all works up to the idea of trust, and especially with VCF 9.0, VMware Cloud Foundation 9.0. So I'd like to start with sort of our approach to security and our approach to all of this stuff. And in fact, our approach when we talk about security and compliance, our approach is security first. Security, you do good security. Security is an always sort of thing, always on. Compliance, you're getting audited once a year, something like that. If that's all you're doing security wise, you're probably in trouble at that point. But, good security is explainable to your auditors, or it should be at least. And so that's actually one of our goals. But we really want our customers to be able to be secure faster. Security itself is not something that advances an organization. It's not the prime thing for most organizations. Some organizations actually do security and they care deeply about that. But most, it's just a means to an end. They want to deliver services, run workloads, that sort of thing. And so where we can turn things on, we like doing that. Where security is always a trade-off in some ways. So we don't turn certain things on because of those trade-offs, but we want it to remain flexible. Not everyone is the same. Not everyone has the same requirements. Many workloads, there's always something, right? So I'd really try to stay flexible there. Recovering quickly. All manner of stuff can happen in an environment, and being able to be resilient to that is really important. Resilience has really been the primary feature since VMware infrastructure software since 2005 or so, when vMotion was invented. And we kind of stopped talking about it, but we shouldn't have. And actually, the EU Digital Operational Resilience Act has, where banks in the EU were really doing a lot of work with that late last year, mid last year, really highlighted all of the resilience features that we have. And we've got a ton of stuff. And, just tactical stuff from failed application upgrades, or de-risking, just day-to-day stuff, or, strategic stuff. What happens if I get run over by a hurricane, and that sort of thing. And so very important there. And then last on my list, really what we're after in VCF, and the real differentiator is trust, inherent trust in the stack. Well, we talk about zero trust a lot. The industry talks about zero trust, but I see zero trust implementations there end up being lots more trust. So zero trust should be less trust, not more trust. And it's maybe just my opinion, but that's, fewer things to secure. The easiest thing to secure is the thing that you don't have, and so reducing the amount of trust, reducing the population of people that can have access, all of that stuff, very important for security. And then being able to replace trust with continuous verification. I mean, there's the old 80s Cold War thing, trust but verify. That's exactly right. Like you can, if you've got data from the last hour that your hosts are all up to date and are running the right level of firmware, all of this stuff, that's really powerful. And so the ability to trust that your platform, your data is where you think it is, data sovereignty is really important. There's a lot of regulations nowadays about data having to remain in certain places, that who's got access, what has access, not just who, but what other systems, that the system is verifiably secure, that it's being monitored, it's continuously monitored, and you can verify the security state of it. Problems, when that changes, should be highlighted rapidly. It should come to people's attention, somebody that can do something about it. Dear human maintainer of mine, I am VCF and you should fix me, that sort of thing. And maybe it's innocuous, maybe it's an actual breach, but a lot of times it's just innocuous. Somebody changed something. I used to change security controls to debug things, to fix things, and then I'd forget to put them back, and then I'd find out about it during an audit. And then resolving things, resolutions to problems should be quick, non-disruptive if they can be. vMotion is a great example of that again, where we can patch infrastructure without taking the workloads down. And so that's kind of the core of how we think about security moving forward. And it really, again, not about security, but about trust. Can you trust your platform? Do you trust your platform, and why? So I'd like to talk a little bit about lifecycle patching, some of the highlights, hit some of the highlights from the security world, things that are pertinent. There's a lot to be said about lifecycle, being able to update, upgrade, patch when there's a patch available. And we've gone through some changes over the last few major versions. Update Manager's gone. We miss you, Update Manager, but Lifecycle Manager is really cool. It cares deeply about the way a system is configured. It's doing the continuous monitoring as well. Hey, a system has extra pieces of software on it. Well, that's not good. Like we should check that out, that sort of thing. And so we've taken a lot of feedback around that. How do we make that easier to use? How do we make it more valuable? Multi-vendor cluster images. In a perfect world, we all get a dump truck full of money backed up to us every couple of years, and we buy a whole new homogeneous cluster. That's not how the real world works. Not in my real world, at least. And so, making that easier to deal with. Taking out some of the friction, HA, the high availability, and NSX components were add-ons and installed separately, and they get into dependency loops. We're one big family now, and VCF, it all just ships as part of it. So that's gone. But also things like GPUs, all this AI, newfangled AI stuff is neat, but we've spent 10 years making GPU usage just one of the gang as far as our workload is concerned, being able to move it around. AI researchers and data scientists can feel important on their own, but from an infrastructure perspective, it's just all the same. And that's really nice, especially in 9. We've really done a lot of work with the vMotion stuff. Live patching and custom EVC profiles, talk a little bit about those here. So live patching is something we announced in vSphere 8, but its scope was so limited, we actually haven't had an opportunity to use it yet, and that's going to continue into the near future too. But in 9, our vision for it is that about 80% of anything that a host needs to be patched for should be covered by live patching, and that's really nice. The ability to not move workloads. Most workloads can move just fine, but there's big ones. There's workload administrators that are jumpy about it. And so we want to, where we can, leave them where they're at. We enter partial maintenance mode. And then partial maintenance mode just stabilizes the machine, nothing going in, nothing coming out as far as workloads. And then it does what it needs to. If it needs to repair and patch the virtual machine monitor, and we'll talk a lot more about the virtual machine monitor in a few minutes here, then we do what's known as a fast suspend resume. It's basically a process-to-process vMotion is what it amounts to. It's milliseconds, nanoseconds. I don't know. I used to say that it could be measured in CPU cycles, but anything can be measured in CPU cycles. Caveat here is DPU and TPM enabled hosts are not yet compatible. DPU's got the ESX running on the DPU itself, so there's considerations there. And TPM's the extra security. So what we're doing with live patch is replacing part of the operating system. And we don't want to we turn on extra security to prevent attackers from being able to do that. So we need a way to authenticate ourselves to the system so that attackers can't do this maliciously, but we can. So it's in process. It's
Hey,
number
Bob,
one
I've got
question.
A quick question there.
Yeah.
The TPM-enabled hosts, we know that Microsoft has made a big deal about future versions of Windows needing a TPM to be enabled. Is this something you feel is going to impact the ability to virtualize, like at this point, workstation endpoints? Or do you feel like this is something that's going to be easily overcome very soon? Like you're working on figuring out how to make this TPM compatibility thing work?
So this is at the host level. This is ESX itself. So ESX is the hardware trusted platform module belongs to ESX, and no workloads touch it. There's no workload data stored there whatsoever. For workloads, we've got the virtual TPM, which is completely separate. It's rooted in VM encryption, so it keeps it secret, safe that direction, and it's not impacted by this at all. So,
okay. Thank you.
If that makes sense.
Since Tom broke in, now we can ask questions. I'll go. How does patching work in the context of ESXi being part of the whole product of VCF? Can I just use this feature to patch just hosts when something critical happens, or does it have to come to me as part of a huge VCF upgrade or patch itself?
It can be both. So we've got a new versioning scheme as well. Some logic has been applied to our versioning. We're not going to have versions like 8.0U3QZSSP whatever anymore. Nobody knows what those are. Everyone knows what Arabic numerals are, and that the versions go up and we have newer stuff. So really trying to do that. So what we've got out on is, like right now, 9.0 was released as 9.0.0.0. Actually, I'm going to use VCF 5.2 as an example. So 5.2, major version. 5.2.1 is a VCF bundle, and you'll get things as that as well. 5.2.1.1 is a tactical patch, basically. And so we're going to apply that. So if ESX 9.0.0.1 is released, that'll be something you'll apply like this. But you can get these patches in both directions. If it's big enough, or and there are time frames associated with these things as well, monthly, quarterly. So 9.0.1, for example, would be a quarterly patch, that sort of thing. So trying to make some sense out of it. But yeah, to your question, you'll be able to see the ESX updates in all of those sorts of ways.
Bob, this is Jack Pollard from Paradigm Technica. Another question on patching, which I know is sort of not really security, but still security, is are patches going to be inclusive, or are admins going to have to be responsible for saying, I need to build up a stack and a chain of patches in order to get my machines?
Oh, that sounds like a nightmare, Jack. No, they're always inclusive. And with very few exceptions over my experience with VMware, basically they're always cumulative. So if you apply the latest stuff, the latest version, you go out into the support portal, download the latest thing, you'll have all of the patches up until that point. So cool. No, good questions. EVC. So making patching easy. Also, if you've got mixed clusters that, so you get different generations of CPUs, you can't vMotion back and forth between them. EVC, enhanced vMotion compatibility, basically smooths out the differences between them, but it's been incredibly hard to use because you had to remember to turn it on when the cluster was absolutely empty, right when you built it, and nobody remembered that. And then, or you got to wait for a power outage or some other catastrophe and then make an unscheduled change, that sort of thing. And so, coupled with that, the CPU generation, CPUs have kind of gone nuts, and there's a whole bunch of different types and varieties, and there's all this edge stuff now that uses all that stuff. We've got the ability to just capture what you're using. And in fact, uses link mode. If you've got your hosts in link mode, clusters are all linked to each other. It'll look at the whole thing and say, here's the baseline for all of this stuff. And then you can just turn it on right where you're at. And so hopefully that will make things a lot easier moving forward for, again, just patching, being able to deal with some of the friction here. Deep inside the hypervisor itself, doing a lot of work as far as security and the layers of security in here. First couple of things, code signing, we've been talking about that for a long time. Our ecosystem's got a lot of inertia to it. We still have partners, vendors out there that are telling people to shut security off because they're not signing their code. You can do that. You can still do that. We're on our way to making that not possible. But if you do that now, you get an undismissible warning that you've got a security problem, which you do. Secure boot. 40% of the world uses secure boot. It's been around for 15 years. It's a great way to prevent malware. Trying to make that easy as well. You can enforce it via configuration profiles now. You can actually just turn it on and switch over to it, and ESX will boot just fine using that now. So shouldn't be any barriers there anymore, except in people's minds, hopefully. So let's talk about the user level monitor, sandboxing, and then confidential computing a little bit too. So inside of ESX, we've got all these different layers of, I often compare it to an onion. You peel it a little bit, you cry a little bit, it's all good. And, but you've got these different layers there. The guest operating system, unless you're running Windows 3.1 or DOS or something, which still run, by the way, you've probably got process protections there. You've got a role-based access control model, something like that. Around that, you've got the VM runtime, container runtimes as well, just a workload runtime. And that's a security boundary. And then around that, in vSphere 7, we introduced a sandbox. Basically, it watches what the runtime does. And if it tries something funny, It kills it and sends alerts. And it's not perfect, but it's a heck of a lot better than it used to be. And these protections are available on all of the workloads running on ESX. ESX itself is a security boundary. There's you can sequester certain types of workloads and certain security, keep the same security levels together, that sort of thing. Then underneath CPU and memory, which about 8 years ago, we discovered that the promises made by CPUs and memory controllers and IO controllers and that aren't necessarily what actually gets implemented. And there's more of those. I mean, recently in the last couple of weeks, there's even been announcements about new versions of Spectre and Meltdown-esque vulnerabilities from AMD and such. So nobody gets out of this one without a little bit of blame. But what do we do about it? So we've got the two main types of vulnerabilities here. Hardware vulnerabilities, where your guest operating system, an attacker that's got access to a guest operating system can coerce the hardware into giving it data it shouldn't have access to. And then you've got the VM escapes, where you can, an attacker breaks into the guest operating system and then can get out into ESX. And you don't want them there either. So as far as hardware vulnerabilities, we'll talk about a little bit about that. Confidential computing, for example, we've had AMD SEVES and Intel's SGX technologies built in since 7. There's follow-ons. Those were kind of hard to use, and they kept secrets from the hypervisors. And so the hypervisor basically takes its ball and goes home, says, I'm not going to help you with vMotion. I'm not going to help you with all this other stuff. And so AMD and Intel came up with new versions of these that help with a lot of that stuff. And so SEV, SMP, TDX, the follow-ons to those technologies. And so AMD in particular, they implement their versions of the confidential computing technology. They've got a security processor. It's an ARM chip that's actually integrated into their EPYC CPUs, which is cool by itself. And a guest operating system that wants to participate can request an encryption key. And it gets the encryption key. Its data is encrypted in memory and in the CPU registers as well. And so that's really nice. And so it's not an all or nothing thing. You can turn certain guest operating systems can enable it. If you've got a guest operating system, if you are running Windows 3.1, you don't have to enable it, whatever. It can be just its own little operation going on there. And then if there is a security vulnerability, and a guest operating system can get access to something it shouldn't have access to, all it gets back is ciphertext. It doesn't have the encryption keys there. So that's a nice, powerful protection. It's actually kind of interesting that CPU manufacturers are basically admitting that they are probably going to have more problems like this. And so, but it's a way to protect yourself. And it's really important in shared environments, especially public cloud. It's been very popular in public cloud because you don't know who your neighbors are. It's a little bit of different security profile. When you're your own neighbor, you own the whole box. The whole box belongs to you, that sort of thing. And so, but building that in, we've got a lot of customers that are running in shared environments and that do want to take advantage of this. So we've got the initial steps here to enable these particular technologies. It does require host hardware support, as would seem obvious. Right now it's delivered via RPQ. We actually want to ask you a couple of questions if you want to turn this on. It's not very onerous. So just, reach out if people want to turn it on. It will be, it'll be in the future, it'll be it's a tech preview essentially, but, more to come.
So Bob,
what's up?
I understand the use case here for confidential computing makes sense. You want to protect from lateral movement. Any kind of idea what kind of overhead, if any, that could introduce on the host itself?
That's a good question. And actually and it's going to get if IT had a motto, it would be, it depends. The workload, it depends on IO, and that there's actually a complicating factor here too. And I'll get to that in just a second. The user level monitor, we implemented this with a change in the virtual machine monitor. So performance testing is actually ongoing right now. It's less performant than the old style, but we're working on it right now. I don't have a specific number. Everyone wants a number. Is it 5%? Is it 35%? I don't have a number for you.
But there is a number out there, and it could vary based on the customer, but there's likely to be some kind of impact that you need to account for.
Oh yeah, there is a number for sure. We don't know what it is right now.
Okay.
And we haven't characterized the workloads enough. So the virtual machine monitor that we've been dealing with is 20 years old, and we've got good characterization of workloads on it. The new one is not that old. And so our performance in the office, the Broadcom office I'm part of, there's a guy that sits down the hall from me, and that's exactly what we're talking about right here is exactly what he's been doing the last few weeks. So, yep. And he was unwilling to give me answers about it as well. I asked the exact same questions. So moving forward, let's talk a little bit about that. So CPUs basically have two modes in which they can operate. The one mode is VM kernel, or the kernel mode, where anything running runs really fast, has no permissions, because that's why it runs really fast, and has the run of the box. User mode is a little different. The user mode is doesn't have run of the box. It's got permissions. It doesn't have permission to do anything really. But for performance reasons, all hypervisors run things in kernel mode, and what makes sense. But that means when you've got a VM escape, you're root, you're administrator, you can do whatever you want there, and so that's not good. So what we're doing as part of this, and you'll see it in 9. It's in 9, but it's not the default yet for a lot of these same reasons, Ken, that we were just talking about. That we're kind of conservative when it comes to this stuff. So it's the default if you turn on memory tiering. It's the default if you turn on confidential computing, but it's not the default. There's some advanced parameters you can set if you want to make it the default or make it a certain percentage of the workloads that you start. But it deprivileges it. So somebody gets out, does a VM escape, gets out of the sandbox even. Well, what are they going to do? They have no rights to anything. And then beyond that, we've taken those sandboxes, the idea of, hey, we've got these sandboxes around the workloads themselves, but what about all these other processes? Well, we applied them to the other processes. So these are just 4 different examples. There's a lot more little boxes I could draw, but they've got a sandbox around them as well. They've got a permission model. And if they try to do something funky, again, killed, alarms, thanks for playing. So, just trying to sandbox as much as possible, contain the blast radius there.
You're basically doing a change route with a VM, like you're doing process services.
Yeah, exactly. Yep. So, the old school vulnerabilities, like the service location protocol, which is gone in 9, by the way, that open source project was unmaintained for a number of years and had vulnerabilities, and we had to issue advisories about it and stuff like that. The problems there could have been contained. Certainly we want to get it fixed, but the idea is to buy time so that you can do the stuff that's not in a panic. And that's nice. So workloads, people want to run workloads on their platforms, and I don't blame them. Most people don't just run VCF for the sake of running VCF like I do. Number of sort of tactical incremental improvements to workloads. The really interesting things here, secure boot. There's a lot of people wanting to do their own secure boot stuff, and that's cool. We support that now. Support that officially now. There was a backdoor way to do it before, and that's been promoted. Hardened virtual USB, we had some advisories about that, and anytime we have an advisory or two about the same subsystem, we'll take a look at it and harden it. So virtual machine hardware 22, you'll see that. Microsoft's Black Lotus vulnerabilities, where they lost control of their signing keys for secure boot. That was not good. They've been slowly, quietly replacing and revoking UEFI certificates over the last few years as part of Windows Update. So if you are running 9 and running the latest versions of virtual hardware, you'll need the latest versions of the Microsoft ISOs if you're doing new installs. TPM 2.0, we bumped the revision on there. There are some feature changes. But forensic snapshots, this is another interesting thing because, again, we're kind of conservative when it comes to operations. And any snapshot that we take, we want to be runnable again. And convincing engineering that forensic snapshots don't need to be runnable. Actually, that was easier than we thought. But forensic snapshots don't need to be runnable. They need to be scannable by a tool, but that's it. So we've got support for that now too. And so that's really nice. I think the biggest thing for me for workloads, we get a lot of resilience features in the platform for workloads, but the VPCs, the virtual private clouds, are really interesting. The idea that you can dynamically create network segments for workloads to isolate them, apply security controls to them, all of that stuff. And you can do it globally, there's all kinds of neat stuff there. I think that's a really interesting thing moving forward. And as NSX becomes tightly integrated, just becomes part of ESX, it's, that integration is getting a lot less complicated to do too, and a lot easier to set up. Cryptography, people are deeply interested in keeping their secrets, and cryptographic methods are how that works. TLS 1.3 is the default all the way around. We can fall back. By default, we can fall back to 1.2. Again, we're a little conservative for backwards compatibility, but you can set that. I'll show that to you in a second. And you can choose your cipher suites as well. I've got slides for all of these things, so I'll just skip into it. Key wrapping. So one of the ways in which you can do encryption is to keep your keys externally in a key management system. And that's great. People do that, but we never delete a key. We actually can't tell if you're still using the key or not. And so people get really angry for a bunch of different reasons. One, they get all these keys in there and they don't know what's in use and what isn't. And two, sometimes you're in the cloud, you're paying per key. It's $1 a key a month. But if you've got 100,000 VMs, that's a 1.2 million bucks in keys every year, and that's a lot, I think that's a lot. And so people asked, and three, they want to rotate their keys. And so that kind of plays into which keys are actually in use. And so we've got a wrapping key now. And so it's not just the two keys, the data encryption key and the key encryption key anymore. We can wrap the key encryption key. All problems are solvable with another layer of abstraction, right? And so we can wrap that key. We can rotate that key. We can give it a name that your KMS provider admin or your KMS admins can find.
So in that case, you are wrapping a relatively static key with the dynamic key store in the KMS that people would rotate. Can we do a force and say, hey, we're not sure of the validity or that the key we've wrapped is compromised? Can we force rotation of that one as well?
Yes. Yep, you can. You can also create. So one thing I didn't mention here, and I'm sorry, should have actually, because so there's this idea of rekeying. There's a deep rekey where you have to power the VM off and you rekey the whole stack, from scratch. But there's these shallow rekeys where you're changing the intermediate keys, and you can do that while everything's online. And so that's how you would do that. You would rotate it through a shallow rekey process. You can either create another key provider to do that, or you can just do a shallow rekey here. However you want to do it, there's mechanisms for that. It's very flexible. Good question. Ciphers, I was talking about this. We've got a NIST 2024 TLS 1.3 only, which will be a popular option. TLS only 1.3, only the two ciphers that pass all scanners globally. You'll have to find other things to talk about with your GRC folks. So sports, weather, international regulatory compliance, whatever. Speaking of international regulatory compliance, the CA Browser Forum, the standards body for browser certificate validity and all that stuff, has over the next 2 years are lowering certificate legal lifespans to 47 days, which sounds like an absolute nightmare to me. I long for the days where I could get a 10-year certificate and be done with it, but I get why, but so VCF has got interfaces for managing these things, being able to see the status of it, renewing them automatically. And we've got things on our roadmap for better support for external Acme protocol, that sort of thing. So a lot of good stuff there. A lot of good stuff. Centralized password management, centralized security operations, auditing, all the stuff that was in ARIA operations prior has become VCF operations, and really doubling down on the auditing and monitoring for security, being able to dive into You get an alert that a security control has changed. Who did it, being able to go into the VCF operations for logs, formerly ARIA operations for logs, log insight, whatever we want to call it. It's all becoming VCF operations, so I'm happy about that. But the being able to dive into that stuff, being able to see who did it, maybe not tell why it was done, but get to the bottom of things more quickly, so you can figure out, is it an actual breach or just junior admin doing something, or senior admin doing something and forgetting, as I said earlier. So a lot of good stuff going on here too. And also for compliance, trying to get ahead of your compliance. So when the auditor shows up, you're ready to go. You don't have any surprises, but also keep it flexible too. So if you've made a business decision to not do a security control, you can shut that off. So it's not always bothering you. Getting towards the end here, access control. Access control is a big way in which organizations are breached, frankly, identity systems. And so being flexible with this, we're also really trying to get out of the business of being an identity provider, because there's so much better stuff going on with real identity providers out there. And if you need an on-premises one, the Symantec VIP stuff works great. Otherwise, we support Okta, we support Ping, Azure AD or Entra ID, but also generic providers as well. SAML, OAuth providers, all of those. You can set up your own as well. And so that's been something that's been asked for. And so there it is. We've got site-wide, VCF-wide unified configuration. You set an SSO up once and it'll configure it on all of the different interfaces. You've also got multiple deployment options. It's the old VIDM stuff, except it's been changed to be a broker. It's the VMware Identity Broker, and it's been embedded in all of 8. It was embedded in vCenter as a broker. It doesn't have its own identity provider stuff in there anymore, like VIDM did, but it can broker connections to other things. And so you can use the embedded one in vCenter. You can have an external, you can have an appliance deployed as part of VCF, or you can have an appliance cluster. So three different appliances deployed, however you want to do that. And then last, we've done a ton of work on APIs, standardizing APIs, a lot of work with OpenAPI 3.0. And some of that is actually programmatic access to the role-based access control systems, which has long been asked for, long been needed, so that people can write stuff to automate these things. You don't have to do weird stuff in the back end. There's standardized interfaces for it. So that's what I've got for you guys. We publish we publish as much as we can. Anytime I run across something that could be public, I've been putting it out in our GitHub repository. And whether you believe in QR codes and their security or not, well, here's a QR code, and it's doubly bad if you swing that way, because it goes to a redirector, which then goes to my GitHub URL. But you can take it out on me and explore sometime when we see each other. And that is my deal. Thank you, folks, and security and trust.